Hey, AP Stats, Mr. McNichols here. Just wanted to post a quick tutorial on how to complete the sampling distribution activity. And so here we go. With the collection box highlighted, what I'm going to do is once you have your data is paste it in. So I just hit Control V. And when that's highlighted, I can pull down a table and my data is in there. And I know one thing that's really good for people to do is maybe make a quick graph of the population. Theoretically, we're not supposed to know what it looks like or the answer and all that kind of stuff. But if you have some data that's categorical, it would really mess you up the rest of the way. So I'm going to grab the years of experience for these football players, drag it down to my x-axis, and since a dot plot came up, whatever the shape, it doesn't really matter. The fact of the matter is that everything there is quantitative. And so actually I'm going to delete that for now because I don't need it at this moment. What I really need is this thing back here. So now down to letter B, I'm going to right click on the collection box and I am going to sample cases. And it gives me a new collection box that says sample of your data. And by default, you don't have to do this here, but if I do pull down a table, it shows me the 10 that were selected. I'm going to hit Control Z, Edit Undo to get rid of it, because what I want to do is increase our sample size so the central limit theorem will apply. And so when I double click on this, it opens up this inspector. And I know in the directions I said click the animation off. You could also uncheck the with replacement because it's not, we don't want the same player necessarily or your same data point to get selected twice. And for the central limit theorem to apply, our sample size needs to be at least 30. And so when I say sample more cases, it basically did that in the background. Again, if you care, you can pull down a table. There are the 30 that it selected. I'm going to hit Edit Undo to get rid of that because what we're going to do is now automate this process where it's going to take samples of 30 many, many times. And we do that under the Measures tab. And so I want to find the mean experience. So I'm just going to give it a name, mean experience. And over here under the formula, I'm going to have to type the word mean with parentheses and tell it EXP. And I'm using EXP because it's my variable. And if you don't want to type out your whole variable, it's listed under here. So instead of typing it in, I could have just come down here and double clicked on it and it appears. And then when I hit OK, so for the one sample we've collected so far, the mean was 2.3667, all that good stuff. But again, what I'm interested in now is automating that process. And so once that is set up, I want to come over here to my sample and I want to collect measures. Now by default then, it's going to give me another collection box. That collection box happens to have, and again, if I pull down a table, it has 5 samples of 30. Well, what we want is, again, more samples of 30 because with 5 samples, and if I pull down a graph and drag this to the x-axis, there's not much of a pattern I can see there just yet. So if I double click on this, open up the inspector for the measures, I'm going to click the animation off. Again, if you don't, you're going to be waiting a very long time. So it looks like I'm on letter F now all of a sudden. But if I go to 1,000 of these, this will collect 1,000 samples of 30. And so I'm going to hit collect measures. And it takes it a few seconds to do this. And again, remember, this is creating a sampling distribution of 1,000 samples of 30, which will then give us an idea of how we can expect a sample of 30 to behave. And so as soon as that's done, here are the results. And I can close out of this, but here are the results. There are over 1,000. It's actually 1,005 because my initial 5. If you don't have that little table there, how you get it is you can click on measures, pull down the table, and there it is. And again, if you didn't have the graph, you could pull down a graph and take this and put it on your x-axis. So here is what our sampling distribution looks like. You can keep it as a dot plot. You could look at it as a histogram, that kind of stuff. But if you have data that is the population data from up here is really, really, really skewed or somehow non-normal, your data set here may look a bit unnormal, not normal as well. And that's okay, but it looks, I'm sure, way better than what it did before. Now the one correction I have to make on here, I said to basically right click on your graph and do the formula mean of your variable. Well, in fact, one thing is you don't actually would ever type in the words your variable or your data, because that was just a generic thing I used. But really what we need to do now is come over here, right click on this graph, and I can say plot value, and I can find the mean of that data. And when I hit OK, it appears and it tells me 3.9 and some change on that. Now, really, I'm now just going to begin to do some comparisons. How does my sampling distribution compare with maybe the graph of my population data? So here's a graph of that. And one of the questions below asks you to compare those two, right? That's the one, I guess it's further down now. To get more analysis of my sampling distribution, I can pull down a summary table. And when I pull mean experience down here, it tells me, of course, the same mean. I can also right click and say add a formula. And the formula for Fathom for standard deviation is simply S with parentheses. So my mean for my sampling distribution is 3.9, and my standard deviation is 0.5835, etc. So that goes with that graph, basically. Now my population graph, I can also have a summary table for it. And if I pull down experience here, it tells me what the true answer that you oftentimes don't have access to really is. So for me, the true answer for the experience of an NFL player who played in the AFC in 2014 is 3.901, and my sampling distribution told me the center of it's 3.908, so it's pretty good. And when I right click and add a formula here, that is the standard deviation again, and when I hit OK, I get 3.26, which should not equal this one over here. And what I'm going to do now is cut off here, because this actually gets into talking about some of the questions that you need to answer about center, shape, and spread. So hopefully that helped. Just take off the one area where I did say right click again as a reminder, and when you plotted that value, just use mean with parentheses, and I'll cancel all that since I already have it over there. And I think that should be enough for you guys.